Well, thank you everybody for joining this July 2025 VMware by Broadcom TAM customer webinar. Today's webinar on VCF 9 is one that we've been looking forward to for quite a while. And the fact that we've by far got our largest registration here today, so tells me that you all are interested in the same topic. Before we get into today's content, there are just a couple of basic announcements to get out of the way. First of all, as you see on the screen right here, that our next TAM customer webinar will be on August 14th. And will be part two of the same topic from today, the VCF 9, looking at what's new. So we have a whole panel of folks here to help with your questions today. Please use the Q&A feature of Zoom to ask those questions, and they will get addressed. If there's any that were unable to get answered completely during this webinar, please reach out to your TAM and ask them to follow up on your behalf. At the end of today's session, you will be prompted to fill out a simple 2-question survey related to the value you receive from this session and any topic suggestions for the future. Your completion of this survey is a valuable gift back to us. We'd greatly appreciate you taking a minute to do that. And lastly, this webinar is being recorded, and your TAM can make the recording link available to you. So as I mentioned already, the topic for today is part one of a 2-part series highlighting the various use cases that VCF 9 addresses. We're privileged to have a whole team of folks presenting and answering questions. And to start off, I'll get out of the way, turn things over to Kyle Gleed.
All right, thank you, Andy. And welcome everyone to today's presentation. So we're going to be passing the ball between multiple presenters today. We have several subject matter experts. We're all part of the VCF division technical marketing team. And so as Andy mentioned, post the easy questions in the Q&A and keep your hard questions for your TAMs, and we'll do our best to answer them as they come along.
I don't think that's what I said, Kyle.
So yeah, let's go ahead and jump in. So VCF 9, of course, is a pretty monumental release for us. This is the first major release since the Broadcom acquisition. And if, hopefully everybody's aware of, some of the commitments we made with regards to our plans to help make VCF the best-in-class private cloud solution, to help bring together the different components into a single unified product. And you'll start to see a lot of those initiatives start to take fold here as we get into VCF 9. In this part one, we're going to start by first going over the VCF 9 installer. And then I'm going to hand off and we'll talk about vSphere 9, some of the new capabilities around, our core vSphere hypervisor platform. And then we'll get into storage with vSAN 9. Then we'll get into some networking with VMware NSX and particularly around virtual private clouds. And then we'll hear about workload migrations with HCX, and then I'll come back and wrap us up again with a little bit of discussion around fleet management and some of the new capabilities we've added to VCF operations. So with that, let's go ahead and jump in. So one of the first things that you'll notice with VCF 9 is we have a new installer. We call this the VMware Cloud Foundation installer, VCF installer. And a couple of quick notes here is, yes, the same installer will deploy both VVF and VCF. So, we have this new unified installer, and it basically is used to deploy the full stack. And depending on whether you select VCF or VVF, will determine on whether which components get deployed as part of this. It does replace the old VCF Cloud Builder. So if any of you are familiar with the old Cloud Builder appliance, you'll remember we had with VCF 5.2 and earlier. It is similar to the Cloud Builder in that it's distributed as a single OVA file, and it's around 2 gig in size. And if you're familiar with the Cloud Builder, you'll remember that was upwards of over 20 gig in size. So it is quite a bit smaller, and the reason for that is because we no longer bundle all the binaries with the installer. So essentially you deploy the installer, and then one of the first steps you'll need to do is going in and set up a depot and download the binaries. And I'll talk about that in the next slide a little bit more. Yeah, so we'll use this installer. We'll see a couple of examples of the screenshots as we go through. But one thing I want to kind of point out here is if you log into support.broadcom.com to download the OVA, and you look for VCF installer, you will not find an appliance. Well, you'll find VCF installer, but when you go to download it, you'll see that the OVA is not called the VCF installer. The OVA is actually called the SDDC manager, and that is because when you go in to download the Cloud Foundation installer, the installer is implemented on the same appliance as the SDDC manager. So the SDDC manager appliance includes both the SDDC manager as well as the installer. When you deploy the OVA, by default, it will run in the installer mode. And then depending on where it's deployed and your topology, it will then get converted over to the SDDC manager mode as needed. So just keep that in mind if you're looking to get started and you're out looking for it. That is not a mistake on the website in terms of, going to the VMware Cloud Foundation installer and downloading the SDDC manager. The installer is part of the SDDC manager appliance. And so as I mentioned, it is a simple OVA. Here we see an example of the UI. So once you deploy it, you connect to it, you'll see this UI. There's really not much to the UI here. You'll see the first thing you'll need to do is go in here and set up a depot and download the binaries. Now, whenever we talk about downloading binaries, of course, one of the more common questions we get is, does it support dark sites? And yes, you can set this up in a connected state where you can basically just go in and assuming you have internet connectivity, you can just provide your download token and connect it directly to the internet, and it will go out to the public repository and make those binaries available to you. It does not download on its own. It does require you go in and manually download, but it will at least list all the available binaries and let you choose when you want to download those. You can download both the vSphere Foundation and the VMware Cloud Foundation, as you see here. If you're not connected to the internet, you're a dark site or you're a disconnected site, or you just have a preference to keep your environment disconnected, that's fine. We do support the offline depot option as well. For the offline depot, you can go in and set up a local web server, and you can use the vSphere download tool to help stage the binaries on that local web server, and then just point the installer to that local depot, which is the offline depot. A third option you have is to use the vSphere download tool, or the VDT. This is a command line tool that replaces the offline bundle transfer utility. That's new in VCF 9, but you can also use that as well. So lots of ways to get the binaries in there, but once the binaries are in there, you're ready to deploy. And you'll notice here we have a deployment wizard, which is essentially just a UI-driven workflow where you basically just go through the steps. It will prompt you for the required information in terms of like networking, host names, DNS, NTP, things that it needs to do deployment. It will prompt you for all those values. And then I'll get to the end, it will do a validation and do the deployment. If you're doing a lot of deployments and you don't want to have to keep going through that deployment wizard, we do have support for using a JSON. So you can basically go in, capture all the information in a JSON specification file, import that into the wizard, and go with that as well. So so that's pretty much the installer. When you get to the installer, you're going to notice some new terms here. We have this new term called a VCF fleet, and we differentiate that from a VCF instance. So essentially with Cloud Foundation 9.0, VCF operations is now a required component. And along with VCF operations, VCF automation is also deployed from the VCF installer as well. And these components, you can have multiple VCF instances registered with an instance of operations and an instance of automation. And so when we talk about a fleet, we're talking about an environment that has automation and operations deployed. And if you're deploying your first environment where you don't yet have a VCF environment with operations and automation, then you deploy a new fleet. If you already have an environment that has operations and automation deployed, already have a VCF environment with those deployed, then you would already have a fleet, and so then you would add a new instance, a new VCF instance to an existing fleet. So the fleet is basically just a reference to the fact that the operations and automation components can span across multiple VCF environments. So in addition to being able to stand up and deploy Cloud Foundation, we also have the ability using the VCF installer to basically point to existing vCenter server instances and bring those existing environments that you're already running in your data center and convert them, or what we call converge in our documentation, into a VCF management domain. So you can take an existing vCenter server, an existing VCF ops instance, an existing VCF automation instance, and you can basically bring those into a new Cloud Foundation environment. So making it very easy for you to get started with Cloud Foundation. You don't have to start over. You don't have to start new. You can take those existing components. The one catch here with VCF 9 is that when you're bringing those existing components in, they do need to be upgraded to version 9. The last thing I'll talk about here with regards to the VCF installer is we have added a new deployment model we call the simple model. And so if in the past when we deployed Cloud Foundation, we had kind of a one size fits all in the sense that, you know, things like NSX Manager and operations and automation always got deployed as 3-node clusters. So when we deploy those, there would be 3 VMs, 3 appliances get deployed, they get configured into a high availability cluster. You know, the feedback from the field is that that's a bit excessive, especially for smaller deployments, for test deployments, lab deployments, edge deployments. So what we've done is we've updated it to allow us to deploy everything as a single node, a single appliance. And so that's the simple topology. And then we keep that HA mode where you can deploy everything with the highly available clusters. That is still an option as well. So for those labs and those edge sites, you can use the simple deployment model. And then for those production environments where that extra level of high availability is critical, you can use the HA model. So we do have those 2 deployment models. So that's the VCF installer. Now, we're going to shift gears here and we're going to leave the installer. We're going to talk about VCF operations because within Cloud Foundation, we have the concept of a workload domain. Hopefully everybody's familiar with the concept of a workload domain. But essentially a workload domain, when we go in and we use the automation of the SDC manager to stand up new infrastructure, we deploy new workload domains. And a workload domain is a new vCenter server instance with 1 or more vSphere clusters behind it. In the past, with VCF 5.2 and prior, we would do this from the SDDC manager, the SDDC manager UI. But with VCF 9, we have now moved that functionality into VCF operations. So you'll see a lot of the SDDC manager functionality is now moved into VCF operations. Some of it's moved into VCF operations, and some of it's moved into the vSphere client. And if you read the release notes, you'll actually read that we are deprecating the SDDC manager UI. And part of the reason, and as such, since we're deprecating that UI, we have to move that functionality. And so we are seeing that functionality split between VCF operations and vSphere client. And one of the most important parts of that is when we're creating new workload domains. And you'll see here's an example of the UI. You can create a new workload domain and you can import a vCenter. So we no longer have a command line tool, a separate command line tool that we need to use. We can just go in and point the VCF operations to an existing vCenter, run the checks, make sure it's in a good shape, and then bring it in. It will bring in the entire vCenter inventory. When we're using the VCF installer to convert infrastructure into a management domain, we require that you first upgrade it to version 9. When using the VCF import feature through VCF operations, we can bring in vSphere environments running 8.0 update 1 and higher, and NSX, and I keep forgetting to update my slide, but just NSX 4.1 and higher. Do keep in mind that when you're deploying new infrastructure, especially when you're importing a vCenter in, the NSX will be deployed in that environment as part of that import operation. So take that into account. And so that's kind of what I have in terms of just a quick introduction to VCF 9, the VCF installer, and how we deploy VMware Cloud Foundation, and then also how we have moved some of the functionality, particularly that VCF import feature, into the VCF operations UI. And so with this, I'm going to stop and I'm going to hand off to Feidhlim, who is going to talk to us about vSphere 9.
Thank you, Kyle. Let me just grab the share. Okay, so I'm going to take you through some of the top features that exist in the vSphere component of VCF 9. Some of these are going to be familiar because they're features that we released in vSphere 8, but we've built and we've expanded upon them. The first feature we'll talk about here is Live Patch. Now, Live Patch is something we debuted in vSphere 8 Update 3. And if you're not familiar with Live Patch, it allows us to patch ESXi hosts without having to do that lengthy evacuation of all your virtual machines, right? The actual act of patching ESX is relatively fast, right? You patch the host, you reboot the host, and it's done. What takes the long time, or what has problems for customers meeting their maintenance windows, is the act of evacuating hundreds of virtual machines is what takes a long time. By being able to patch ESX in with the VMs in place, we're removing that huge time sink of evacuation. Now, with VCF 9, we're able to patch a lot more of ESX using the live patch method. We can patch components of the VM kernel. the user space, that would be things like the host daemon, NSX components, and the VMX components that we introduced in 8 update 3. So this will allow we expect that this will allow us to release more frequently. Our security patches will be able to take advantage of live patch. And the first security patch that we released this week for VCF 9, it can use live patch. So you can take advantage of this technology finally today in your environments. Now, a couple of other things that we've made better in VCF 9 with regards to live patch is the fast suspend resume capability. This is something that it's not a new technology. It's something that virtual machines go through when you do any sort of live hot add operation to a VM. It's essentially a reload of the VMX process, and it's non-disruptive to virtual machines. However, with vGPU-enabled VMs, that reload takes a little bit longer because we have to reload some of the GPU processes as well when we're working with that pass-through hardware. And we've made it a lot faster and less disruptive for those GPU-enabled VMs in VCF 9. Some typical internal testing that we've done, we've seen some GPU-enabled VMs with 48 gigs of memory going from a stun or a fast suspend resume of approximately 80 seconds all the way down to under 4 seconds. So we've really made some huge improvements there for the GPU-enabled VMs. For non-GPU-enabled VMs, there's nothing to worry about. The stun time is so minuscule, it's non-disruptive. There are a couple of VM types that just don't interoperate with the fast suspend resume, and this is typically VMs that are enabled for vSphere fault tolerance, because you do have that those two VMs in lockstep with each other. We also do have a limitation with live patch where we don't support hosts that are enabled with TPM 2.0 devices, but that is a priority on our roadmap, and we expect that to be that interoperability to be there in VCF 9.1. Now, sticking with the lifecycle team, another ask from our customers, when we introduced vSphere Lifecycle Manager back in vSphere 7, it really required all your hosts in the cluster to be homogeneous, be the same make and model. You could have some flexibility with the model, but it typically did require you to have the same vendor, the same make of host. And this has been an adoption blocker for some customers, and they've had to stick with the baseline method of doing things. In VCF 9, we now have full support for mixed vendor clusters using the vSphere Lifecycle Manager single image model. Essentially, what we do is we still have a single cluster image, and the ESX-based version is uniform across all hosts on our cluster, but we can define additional images or think of them as child images. And within those child images, you can customize components of the vendor add-on, the firmware, the components to suit the particular subset of hardware that you have. And you can assign that additional image then based on a couple of things like the vendor string. You can assign based on the IP range of your host. So it's very easy to actually allocate the additional images to your clustered hosts. We have support for up to 4 additional images in VCF 9. This will give you a theoretical maximum of having up to 5 different hardware vendors in a single cluster. Now, that's not something I would necessarily recommend unless you do have an explicit use case and need for that. Where possible, we still do recommend that you try and keep your clusters as uniform or as homogeneous as possible. Now, another aspect that we did introduce in vSphere 8 is memory tiering. This was released as a technical preview in vSphere 8 and had a bunch of limitations and certain caveats as well. Wasn't supported in production. It's now fully supported in production with VCF 9. Now, what memory tiering essentially does, in a nutshell, and Mike, we do have a session at VMware Explore that'll go into a lot more detail on this. So if you're attending, I'd urge you to sign up for that session. But in a nutshell, memory tiering allows us to install NVMe devices or claim NVMe devices within our host and present them as memory to ESX. If you had a terabyte of DDR memory in your host and you add a terabyte of NVMe storage and claim it for the memory tiering, ESXi will see 2 terabytes of memory. Now, what it does under the hood is it will automatically move cold pages to the slower NVMe memory tier and keep the hot pages and free up more capacity for hot pages in the faster DDR memory. This is typically enabled at a cluster level, and you can mix hardware here. You can have some hosts enabled with memory tiering and some hosts without memory tiering in the same cluster. And you can also disable it at a virtual machine level. The reason why that's important is not all workloads are actually going to benefit from memory tiering, from having their cold pages moved to NVMe storage. Some common examples of that would be high performance computing applications, in-memory databases. They may actually see a performance degradation by having their cold pages moved. One use case where this is really going to hopefully drive greater VM density is VDI desktops. So being able to have even more desktops, VDI desktops on one ESXi host by increasing the total memory available to those VMs. Now, sticking with the hardware acceleration theme, the next couple of slides are all on GPUs. We've been working with NVIDIA and the vGPU technology for several releases now, and really increasing the performance, the non-disruptiveness of vMotion for GPU-enabled VMs. We want GPU-enabled VMs to have that same just non-disruptive, seamless mobility that we've had with vMotion for years now. And we're really hitting new strides in VCF 9. I mentioned that the fast suspend resume is even faster. That'll benefit customers being able to live patch those GPU-enabled VMs. We've also improved the speed as to which we can vMotion and transmit the GPU data from the source host to the destination, improved the transfer of that information. We've also really dramatically improved the stun times that are needed to facilitate some of that data transmission. For example, we're down to under 2 seconds of a stun time for a 48 gigabit GPU profile. If we take super large GPU profiles, things in the 600 gigabyte range, in previous releases, the vMotion of those VMs would fail. It would time out, it exceeded our abilities. In VCF 9, we're now seeing those vMotions complete and the stun times complete within about 20 seconds. So that's a huge, again, performance increase on the vMotion capabilities of vGPU-enabled VMs. Because we're seeing a huge uptick in the GPU workload space, we're giving more visibility into the usage and the capacity for the vSphere administrator. So at a cluster level under the monitor tab, you'll see this new GPU profile utilization view. And you can see at a high level, you can see all your profiles, the number of consumed instances or the number of VMs consuming that profile, any remaining profile space, and the overall utilization. So it gives the administrators at a glance look at their total GPU consumption of a cluster and help with forecasting and identifying maybe some workloads are using too much of the GPU resources and we might need to reallocate some profiles or reduce the profiles. And in addition to that, we've made vSphere DRS a lot more GPU aware. If we take a look at the diagram on screen, we've got 3 ESX hosts and they've got each VM is spread across each of the hosts. It looks like optimal placement, right? In a non-GPU world, this would be a typical DRS placement. We've spread the load across our 3 hosts in the cluster. However, we now have a GPU-enabled VM that wants 4 GPUs. It wants to take advantage of 4 GPU slots. We have 6, but they're spread across the 3 hosts. And as you know, a VM can't run across multiple hosts at the same time. So what DRS will learn from the historical use in the cluster, it would actually make a placement more like this, where it would fill up the smaller VMs onto one host first to make sure that we do have space for potential future larger GPU workloads. And this will allow our larger GPU-enabled VM be deployed, be placed, and be powered on. Now we can also take this a little step further and create reservations in the supervisor namespace functionality for our GPU-enabled VMs. Similar to memory and CPU reservations, these GPU reservations can be created ahead of time and guarantee that the consumers of this supervisor namespace have the resources that they need to deploy those virtual machines. And lastly, just a quick note before I hand it over to Pete and for the vSAN space is just a mention of virtual hardware version 22. We typically release a new hardware version with new vSphere releases, and VCF 9 is no different. And so we're increasing some of our maximums. Our vCPU maximum goes up to 960 for those super giant monster VMs. We add support for the latest Intel and AMD CPUs, as well as the latest guest operating systems. There's an initial availability for what we call confidential computing using AMD and Intel technology. You can reach out to your TAM for more information on that. And you do need hardware version 22 as well to take advantage of that technology. And then some minor things like the TPM specification is just revised to keep up with industry standards and Windows requirements. New guest customization APIs to allow you to customize guests while they're powered on. Previously, they had to be powered off first before you could inject that guest customization. 4K and block size and read-only virtual NVMe devices as well are brought to the table with hardware version 22. So that's just a teaser of some of the highlights in the vSphere release for VCF 9. And with that, I'm going to stop sharing and hand it over to Pete.
All right, thank you very much, Feidhlim. Let me go ahead and share my screen, and we will kick off this portion of the presentation where we're going to take a look at what's new in vSAN for VCF 9. We've had a lot of really new compelling features, new capabilities, enhancements, and so forth. And this portion of the presentation is just a subset of those. And so I wanted to highlight a few of the key improvements. And one of the most compelling ones, of course, is the introduction of a brand new global deduplication capability within vSAN ESA. Now, many of you who are familiar with vSAN may remember that we had deduplication, a form of deduplication available in the original storage architecture, or OSA. But this is a brand new global deduplication capability within vSAN ESA. So this is really all about driving down the cost of storage and making your environment much more efficient, essentially. Now, one of the things when we look at global deduplication within vSAN ESA is we need to look at its overall effectiveness. And we make this much more effective by making it a cluster-wide capability, meaning that the deduplication domain is the size of the vSAN cluster. Historically, with the implementation of deduplication in the original storage architecture, that was limited to a discrete disk group, meaning that you could have exact matches of data throughout the cluster, but it wouldn't be able to deduplicate that data. Now that we have a single cluster-wide deduplication domain, that's going to increase the probability that it's going to be able to find exact matches and reclaim that free space. Next up is that we wanted to make sure that the design of deduplication within ESA was not going to impact the performance of your mission-critical guest workloads. So this is an activity that runs asynchronously, meaning that it's going to perform in a post-processing time at some interval that is outside of, let's say, your normal business operation windows and so forth. It's going to automatically detect when the resources within a vSAN cluster are not being used as much and will consume those resources for the process of deduplication. So it's a great way to use the resources as a part of the cluster, but not interfere with the performance of the VMs. And of course, it has full integration with the variety of vSAN data services, things like data compression, snapshots, clones, and so forth. Now, one thing I do want to note is that this is released as a part of the first patch within VCF 9.0, so patch 01. It's also under a limited availability, meaning that we're going to initially limit its availability based off of certain conditions that the customers may have, certain sizes of clusters and so forth. So if you're interested in this capability, just reach out to your TAM and they can sort of walk through that process for you. We're really looking forward, though, to this new capability. Now, you may be thinking, well, wait a minute, I have a storage array that has deduplication. It seems to work pretty well. Why is this better? Well, one of the things I want to highlight here to help illustrate the differences is that what happens when you have an environment with a 3-tier architecture using a storage array using a deduplication. If you're growing that environment and you add another storage array, that's in this particular case, what happens is the storage array's deduplication domain is limited to the array itself. So when you add another array or 2 arrays or 3 arrays, you are splitting the deduplication potential in half, in quarters, thirds, whatever the case may be. With vSAN, this is very different. As you add additional hosts and you grow the size of the cluster, it remains as a single deduplication domain. So this means that your effectiveness is actually going to improve as the size of the cluster grows. That's really quite different than any other solution out on the market. So imagine a scenario where you're storing more data, and because you're storing more data, you're getting a much higher effective deduplication ratio. Now, another new feature that we have introduced relates to vSAN storage clusters. Now, vSAN storage clusters is our centralized shared storage solution for vSphere. And this is simply a deployment model within vSAN. You can choose an aggregated vSAN HCI arrangement or a disaggregated vSAN storage cluster arrangement. The new feature here that we're referring to is called network traffic separation. And what this is going to allow you to do is to use multiple VM kernel ports and tag those individually so that one of the VM kernel ports is responsible for the backend vSAN traffic that is responsible for making sure the data is resilient, rebalancing the data, repairing the data if there's an issue, and so forth. Then the other VM kernel port is tagged for the front end guest VM IO that is coming to and from the vSphere hosts and the vSphere clusters that are mounting the data store of the vSAN storage cluster. This does 2 things, really, is that one is going to improve the effective performance of the vSAN storage cluster because we're using more resources in a much more effective way. 2 is that it's going to offer a lot more flexibility as far as a data center arrangement, as far as the servers, where they're located in the racks, and the network traffic traversing the spine leaf arrangement. So imagine you could have a single rack with a vSAN storage cluster, and you can use network traffic separation to ensure that the backend vSAN traffic never traverses across the spine. It stays within the top of rack switches. This is really about driving much better efficiency, improving the flexibility, and and also relieving some of the burdens from your network team in some of the aspects of network design that they need to do in order to accommodate vSAN storage clusters. Now, we've also made some nice improvements for vSAN file services. Of course, vSAN file services is a cluster-based toggle that you can enable on an as-needed basis. And we've improved the effective number of file shares that we can support for vSAN file services per cluster. The previous maximum used to be 250 file shares, but we've doubled that now up to 500 file shares per cluster. Now, this has really come a long way just in a couple of versions here, because our previous maximum just a few versions ago was 100 shares. So you can see where we're going with this. We want to make sure that our customers have this ability to deploy a lot of file shares for a variety of needs. Most often, this is coming up with customers who are using cloud-native applications where they need persistent volumes deployed for those stateless or stateful applications, and this really goes a long way in making those in making that much more effective and useful. Now, with vSAN for VCF 9, we are also introducing vSAN to vSAN replication. And this comes as a part of the VMware Live Recovery add-on. But what this does for you is that it extends the functionality of a capability that we first introduced in vSAN 8 Update 3 or VCF 5.2. And that was known as vSAN data protection. This was a mechanism that you could protect VMs using vSAN ESA's a highly efficient, fast snapshotting engine. And you can protect the VMs in a way that you always wish you could have using snapshots. You could set frequency schedules, retention schedules, group VMs together, and then kind of use it in a set it and forget it manner. Well, we've extended that functionality now to protect VMs where you have a target location is another vSAN cluster. And this is going to offer up a lot of flexibility for customers who want to be able to protect these workloads elsewhere. Now, I mentioned that this is a part of the VMware Live Recovery add-on, meaning that this is a separate license that is on top of VCF that will unlock this ability. But what that also allows you to do is that it allows you to provide full orchestration and failover, failback, and recovery scenarios, because part of VMware Live Recovery is the VMware Live Site Recovery, previously known as Site Recovery Manager. So now you have all of these orchestration capabilities in terms of being able to plan and orchestrate a failover in some sort of failure scenario. Now, we've made a lot of nice new improvements here with stretch clusters for vSAN, and we'll just sort of walk through a few of these here. One of them is support for vSphere clusters that are stretched across two physical sites that are mounting the data store of a vSAN storage cluster that is stretched across two physical sites. So think of this as a much, much easier way of making essentially what is seen as a metro storage cluster. Metro storage clusters is usually deployed through storage arrays, where you have an exact same make and model of a storage array in both locations, and then you have to do a lot of configurations in order to make this happen. And they can be very finicky to not only design, but to operate and troubleshoot. What this allows you to do is now to use vSAN storage clusters in this arrangement, but do it in an easy way. And what this will do is that the vSphere clusters can be defined in a manner where you can define each respective site or fault domain so that it understands how to handle it under failure conditions. Also being able to handle the I/O path in the most efficient way to understand which path it should take in a normal operating condition. Next up, we've also introduced a brand new site-wide maintenance mode feature within a vSAN stretch cluster arrangement. Historically, if you wanted to perform some maintenance on an entire site within a vSAN stretch cluster, you would have to walk through a series of steps in order to make that happen. Now that is simply a part of the user interface, and it will do all of the pre-checks and walk you through what exactly needs to occur. Also on the end of that workflow, of course, it will help you return that stretch cluster to a normal operating state as well. And should there be an issue during any sort of maintenance mode event for a site-wide maintenance mode, such as a double failure, and there's with maybe little hope of those other sites ever returning, we've introduced a new manual site takeover capability that is a part of vSAN for VCF 9 that will allow you to essentially recover the VMs and the data that is on the one remaining site that was in maintenance mode, and be able to power up and spin back up those VMs in a cohesive manner. And this was something that would normally need to be done through our global support team, but now it's a self-service activity. So that concludes my portion of the presentation. So I'll go ahead and stop sharing and pass it on to Dimitri.
Perfect. Thank you very much. Let me share. Here we go. Here we go. Hello. So let's talk now about networking. The networking in VCF 9.0 has its own large load of enhancements. But because that session can only be 15 minutes, I decided to highlight one specific enhancement, Virtual Private Clouds, VPC, and specifically vCenter VPC. Now, of course, to give you a complete picture, I'll have at the end a complete list of enhancements, but I won't be able to go here in details for each of those. So here we go, Virtual Private Clouds, VPC. First, what is it? That's the same as what you have in public clouds. That's a network bubble cloud tenants can create for their applications. They can create one or many networks within their bubble and then plug their applications in them. And they can also control the communication allowed or block they want for their bubble. Now, all that can be configured through a UI, click, 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 or through orchestration such as vCenter Power CLI or VCF automation or any other orchestration tool you like, such as Terraform. And so at the end, you have a bunch of network bubbles, VPC, for each of your application's divisions. And by default, VPC can't communicate with each other for security isolation. But of course, communication can be allowed. So now, how does it work? So let's say you have a VPC with a couple of subnets, web and app. And here we're talking about VCF, so those are inside hypervisors ESX. And those ESX are connected to a couple of networks, vMotion, vSAN, management, not represented here, and one I'll call vNetworking, which is your NSX TEP overlay network. So within a VPC, you have automatically a VPC gateway, which is a distributed router, so inside each ESX. That said, for visual simplicity, I'm showing it here only in ESX1. And so when a VM needs to reach its default gateway, it always does it locally. Then if it needs to talk to another VM which is physically in another ESX, then that traffic is encapsulated through our NSX step tunnel. And so the physical fabric doesn't need to know anything about those networks. So we could see that all traffic within a VPC is completely decoupled from the physical fabric, and so I can represent it like this. But VPC benefits go beyond those networks bubble creation. VPC, now available in vCenter, simplifies greatly the job of the vCenter admin. Let's look at the history of the vCenter admin tasks. 15 plus years ago, when the vCenter admin had to deploy an application, he went to vCenter, created the compute and storage of its application, and then had to open a ticket to ask the network team to create a new network or new networks for his application. So the network admin would create a VLAN, a subnet, a default gateway in his physical fabric, would advertise that network through its physical fabric, and may add some NAT. And then finally, the network would be created and the ticket closed. From there, the vCenter admin would create a VDS port group VLAN, and finally plug his VMs on it. Job done. But as you can see, pretty slow and with one ticket. But yeah, the job is done, and we still have customers following that vSphere model today. But let's now do a fast forward to something like 10 years ago with the introduction of NSX, network virtualization, and let's look at that model in details. Here, the vCenter admin is also admin of the NSX component. So when he has an application to deploy, he would go directly in NSX and create the logical network on his own, fully decoupled from the physical network, and plug his VMs on this logical network. Much faster, also simpler, but the vCenter admin needs some network expertise to be able to follow that model. So we have some customers where the vCenter admin does not have such expertise, and so it goes through a ticket system again, like in the old vSphere model, to get the network done by the network team. The network team would go inside NSX to create the network in logical space. Why? Because it's much simpler to create network in the logical space. The advertisement of networks is automatic. The network is available anywhere in the data center or across data centers. So plenty of benefits to create the network in logical space, but still through a ticket system for the vCenter admin when it does not have network expertise. And so some slowness there still. So now here we are in VCF 9.0 today. Here you have the vCenter admin that can fully deploy its application, so compute, storage, and network, and this without any networking expertise, without dealing with any IP addressing for his applications, because those IP addressing are managed by the network team. And so now he can do it fully from his vCenter UI or API he loves. And instead of explaining through that slide how it goes in details, let's see this with a lab where I will create application through vCenters, compute, storage, and network via vCenter UI and also API. Let's see this now. Now to clarify everything, let's go through a demo of VPC through vCenter. Here is my freshly deployed VCF workload domain and its vCenter. Let's use vCenter now to deploy two new finance and marketing two-tier applications with dedicated isolated networks for each. The vCenter admin already deployed the compute and storage of that application with the finance and marketing web tier and DB tier VMs. And now the vCenter needs to create the network for those two-tier applications. But this time the vCenter admin won't open tickets to ask the network team to create the new VLAN, default gateway, DHCP servers for each finance and marketing application. The vCenter admin will create those directly from vCenter on his own. So for that, he goes to vCenter networking and virtual private clouds. And you can see that at the VCF workload domain deployment, the network connectivity has been completed. And it has been completed with an external IP block 3131.00/16. So any new VPC public network will come from that block. By the way, that IP block was provided at the deployment of the VCF workload domain by the company network administrator, who obviously owns all IP addressing in the company. So let's go back to VPC and create that VPC finance. I'm calling it VPC finance, and let's provide a private IP CIDR 10.151.0.0/16. The company network admin is not involved in the VPC private addressing, since those private IPs are limited inside the VPC. They'll never be used or be seen by the physical data center and the outside world. So that's it. The vCenter admin creates a VPC, a virtual network bubble for his new application finance. Now he can create the two subnets, public and private, needed for that application finance. So let's create the first subnet, FinWeb, and let's make it public because I want the external world to be able to reach it. And let's make it small since I have only one IP, so 16 is more than enough. And let's use DHCP for my VMs. And now let's create the second subnet, FinDB, and let's make it private because I do not want the external world to reach it. Only the web tier can be reachable by the outside world. Now let's plug my finance VMs to those VPC subnets. There are two ways to do that. Directly from VPC, and that's what I'm doing for my web tier VM. or editing the VM. And you can see here for my DB tier VM, I have the VPC networks in their own tab to help the vCenter admin to select the right network. Let's power on now the VMs. And waiting for the application to boot up, let's look at another cool thing available in vCenter VPC. Here you have a nice graphic, a nice representation of the VPC networks with the different subnets and the VMs attached to them. And directly from here, you can also see the VM IP address. So here is my web tier IP address, and I can access the new finance application that the vCenter admin fully deployed, compute, storage, and network from vCenter UI. And here we go. The external users have access to the web tier, and the web tier has access to the DB tier. And you can see the external users do not have access to the DB tier. Now, if you want to provide external users access to the DB tier, then the vCenter admin on his own can create a one-to-one NAT, also called external IP, for that DB VM on a private network. Here we go. So now external people have access to the private DB VM through its external IP public, and that access can be via ping, or that access can be via any other protocol such as SSH. Okay, so the vCenter admin fully deployed the finance application, compute, storage, and network, and he needs to do now the new marketing application. So the vCenter admin could follow the exact same steps with 50, 60, click, click, click. But this time he doesn't want to do it via UI. He wants to do it in a faster way through automation. And for that, he will use PowerShell, a PowerShell script that will do all of that. So here is the script. And let me launch it. In a couple of seconds, the whole marketing application is deployed, compute, storage, and network, by the vCenter admin through a single click or a single script. From the UI, the vCenter admin can now look at the new VPC marketing topology, or can look at all the VPC topologies. And from there, he can find a specific VM IP, such as the marketing web frontend VM. And so now, with this information, external users can access the marketing app. Here we go. And now, if people want to access the DB tier app, which is in a private subnet, that's through its external IP, which can be easily found also in the vCenter VPC topology. Here we go, 31.31.03, and I can access it now. Okay, and so if we wrap up, the goal of VCF is really to enable public cloud experience in your private clouds, and VPC is the core component or the core building block for this capability. And VPC rely in the background on NSX, virtual networking, which is included in all VCF and can be, as you've seen, managed in vCenter. But VPC, they can also be used by other components such as VCF automation, VCF operations, VMware Kubernetes services, and HCX. Here we go. As I said at the very beginning, there are more than VPC and vCenter VPC enhancements in VCF 9.0 under networking. There are some other services under advanced networking, such as now an option to go without NSX edge node, but still offer network services such as routing, NAT, and DHCP. There are enhancements also under management and operation with things like a new NSX dashboard that will give you in a single page all NSX infra health. There are other enhancements around performance, scale, and high availability, and also in other miscellaneous topics such as tighter integration with VCF, with unified SSO and certificates, and now the ability to VCF import a non-VCF vCenter NSX environment. Okay, thanks for your time. I'm running out of time now in my 15 minutes window. We can go deeper in any of those topics if you want at a further date. Thanks for your time, and let's talk now about the next topic.
Thanks, Dimitri. Great demo. Let me share. Okay. So hello, everyone. In this part of the session, we'll dive into what's new in VCF operations, HCX 9.0. Can you guys see my screen?
We do see it. Yep.
Perfect. Thanks. So for those who might not be familiar with HCX, a quick introduction, maybe a minute and a half, and then we will jump into what's new in VCF 9.0 and recorded demo. So I'll show the migration of a virtual machine to one of the VPC, just like what Dimitri created. If you're not familiar with HCX, it's a very powerful workload migration and mobility solution. It's built from ground up for large-scale, non-disruptive workload migration, supporting various scenarios like migrating workload between vCenters. So if you have older version of vCenter and you like to migrate the workloads to maybe latest and greatest VCF, you can use HCX to do that to non-disruptively migrate your workload within different vCenters and also from different hypervisors. So if you are consolidating maybe from a KVM or Hyper-V environment into vCenter environment, into VCF, you can easily accomplish that. And even ability to migrate between different CPU hardware vendors, so in between Intel and AMD and vice versa. And since HCX is integral part of VCF, all its features and functionalities are available with your existing VCF license. It is a very mature solution. We have done well over 1 million virtual machine migration using this technology. And I think its success truly excelled in two areas. One is a networking piece, and the other one is the migration type, diversity of different migration types it provides for different use cases. And regarding the networking, it provides the underlying networking plumbing between the data centers, including L2 network extension. And this makes large-scale, non-disruptive migration possible, supporting up to 1,000 virtual machine concurrent migration with HCX 9.0 version. And it offers diverse migration types such as bulk migration, replicate assisted vMotion, or RAV in short. And these different migration type enables crucial use cases like lift and shift of the maybe entire data center or migrate crown jewel appliances with minimum to no downtime and creation creation of migration waves. So you can take your time to migrate maybe certain racks first or a different application, and it has a really nice tie-up with VCF operations for network to do application discovery, find the dependencies of the application, what type of network it's using, create, excuse me, and we'll go over that a little bit in the presentation. You can do all that, including maybe rebalancing of racks or even within VCF clusters. And we often see that during the hardware recycle, refresh cycle. And the best part is that HCX do all this without deploying any agents in the guest operating system or having required for the most migration type, having a required to boot virtual machines. Okay, so now let me click and proceed with the presentation.
Not hearing the sound, Puneet.
Okay, thanks for pointing that out. Let me try to reshare. Let me find my Zoom. Stop sharing. Share with sound. And let's try again. Next, let's go over what's new in HCX 9.0. We are very excited to announce support of new destination networks in HCX 9.0, and I have few slides to walk through each of these with some examples of supported scenarios. Now, the animation showed the supported scenario. They're not all the supported scenario because the animation will get really busy. So I pick and choose scenarios that are supported. So we'll start with the support for virtual private cloud or VPC. So customer can now non-disruptively migrate their virtual machines into a VPC subnet. This means you can easily move virtual machines from perhaps VLAN backed network that might be running on older version of vCenter directly into latest and greatest VCF 9.0 VPC subnets. And this includes the HCX capability of network extension or L2 network extension. So customers don't have to change IP addresses or MAC addresses of these virtual machine when migrating into VPCs. And this makes it incredibly easy and seamless to adopt new VCF capabilities like VPCs. Another one is HCX 9.0 support for workload migration into a supervisor cluster. So the networking of supervisor cluster is handled via VPC. So HCX can now be used to migrate workload directly into those VPC subnets. And it's important to note a couple of specifications for this use case. HCX 9.0 currently support only the bulk migration type for the supervisor cluster migration, which means the virtual machine reboot is required for this use case. And L2 extension, HCX network extension capability is not available for this particular use case. Next, HCX 9.0 now includes support for migrating workloads into NSX federated environment. This means that federated segments like global and local segments are now available within HCX when you are creating your mobility group. The L2 extension capability is not available for this use case as HCX prioritizes the NSX federated network. So, in a global segment, it's a extended network and prioritizes the federated or NSX network extension over HCXs. So I have a couple of use cases here or scenarios that customer can use this functionality for. Furthermore, HCX 9.0 also includes support for NSX VLAN segments. So for example, if customer has a use case of migrating workload from their current NSX VLAN into maybe a VPC subnet, they can now use HCX for non-disruptive workload migration. Importantly, the HCX L2 network extension capability is available for this network type. And, I'm clicking through some of the scenarios that are supported. All right, for next couple of slides, let's switch gears as we will talk about migration planning. Time after time, we have seen that when customer dedicates sufficient time to planning their migration success rate increases tremendously, right? So knowing that, we are very excited to introduce a step-by-step guide to build a migration plan right within VCF operations for networks. This is an integrated planning process that covers both source and destination side and perform various steps to help build this migration plan. Things like application discovery, so what virtual machine makes up certain application, and then dependency mapping. What are the dependencies for that application? What are the common services it regularly talks to? What type of network is required, and also like checking resource availability, right? So what kind of resources it utilizes on the source side and the current side, and those resources available on the destination where the migration will be happening. So it checks all that, and then it creates an automated migration wave, which include cohort of VMs that consist of certain application, along with best network to use for the migration, including HCX network extension, and with just a click of a button, when we go through this process and it's done in VCF operations for network, with a click of a button, the migration wave can be easily executed via the HCX. Next, let's go over a demo. In this demo environment, I have already pre-created HCX network extension. So I stretch my VLAN network into my VPC subnet, and we'll start with the migration process. We'll click on the migrate and create a new mobility group. Here we'll give mobility group a name and select our virtual machine. So for this demonstration purpose, I'm only going to select one, so it'll be faster. And we'll spend most of the time on this screen. So this is where we will be adding information regarding my destination side. We'll start with the compute. We'll select our cluster, and then next is the storage. On the destination side, which storage the virtual machine will land into, and the migration profile. So earlier we talked a little bit about different type of migration type within HCX. Here's the list of those migration type, and depending on the use case, you can pick and choose which direction you want to go. For example, HCX vMotion, the first one, provides the regular vMotion that is available from vCenter, so you can do the same from here. And then bulk migration is the migration type that could be migrate a lot of virtual machine, up to 1,000 virtual machines. This requires reboot of the virtual machine. So a lot of external features like to update my virtual machine hardware. I would like to update my VM tools during the migration process. I have some custom script I would like to run in the operating system of the VM as I'm during the migration process. I can do all that through the bulk migration. And replication assisted vMotion is really the best of both vMotion and bulk. So you can do a lot of virtual machine at a time, but it's end of the day, it's a virtual vMotion capability, so no downtime, and keep your IP addresses, MAC addresses, and all that. HCX assisted vMotion is HCX orchestrated, so you can do a lot of virtual machine at the same time, and of course do the scheduling of those migration with HCX assisted vMotion. And cold migration is similar to the vMotion, but it's for the virtual machines that's been turned off. So for this demo, we'll pick RAV, or replication assisted vMotion. And next is the optional folder. If I like some folder on the destination side, this is vCenter folder, the virtual machine to go there. I can pick that. Same with the source formatting. I can, if I have thin provisioning and want to change to thick, vice versa, I can do that. If I want to keep the same, that's what we'll do in our demo. We can select that information. Next is the scheduling. So this is very powerful. You can, if you have a certain maintenance window, maybe Saturday 11 p.m. we would like to schedule it for that time. You can schedule those kind of windows. There are two types. One is a transfer. So especially for the replication assisted view motion, you can do the transfer time that, okay, transfer might start right away, but the cut or switchover will happen on Saturday evening. So in this demonstration, we will just do it right away. So I'll cancel for now, but those kind of options are available to you. There are a lot of other extended options available that customer can use, like as I mentioned previously, upgrade virtual machine hardware, upgrade virtual machine tools, duplicate the security tags. These are NSX security tags, and all the other options that are available, you can see. Next, we will click on the virtual machine itself and look into the network. Because I already extended the network, it knows which network the virtual machine will land into, which is the VPC subnet. So it's smart enough to understand that. But if I had to pick a different one, I can click on that NSXT VPC subnet. It's really nicely organized for VPCs, and I can click on my the subnet that I would like to pick it and execute the migration itself. So first we'll go ahead and validate it. Okay, validate went through, and next we will go ahead and start the migration. Now the migration will take some time, but we can do other things, like we can look into, as the migration is happening, we can check the events. So these are the live event that is happening as the migration proceeding, so customer knows what the state of the migration at any given time, and it goes through the whole process of showing the migration. So this concludes our demo, and I'll hand it over to Kyle. Thanks.
All right, thanks, Puneet. Let me share my screen now. And so I am going to wrap us up today with the final section. We're going to be talking about a new feature referred to as fleet management, and this is part of VCF operations. So as part of VCF 9, as I alluded to earlier when I was talking about the VCF installer and the bifurcating of some of the capabilities of the SDDC Manager UI, and some going into the vSphere client, others going into VCF operations. This is another area where we see a lot of the functionality that has traditionally been part of the SDDC Manager, the automation to do things like manage passwords and certificates, have been moved into the VCF operations, and these capabilities have been moved into a new section in VCF operations referred to as fleet management. So this is just kind of a quick summary of some of the things we'll talk about. But of course, if you're familiar with VCF operations, you'll know that for the longest time, VCF operations has been a great tool out there for helping to monitor the health and performance of our vSphere environments. Everything from health and diagnostics to integration with logs. We have integration with network, VCF operations for networks, as well as views into our storage and integration with vSAN, and do just general, troubleshooting, general visibility into our environments. That's, what VCF Ops has been known for. And if you're using it today, you're likely using it, for one or more of these types of reasons. And as I mentioned, with VCF 9, we've now added this new section called VCF Fleet Management. And in VCF Fleet Management, we have a number of new capabilities, identity and access. So we now have a single identity broker that's shared across the full SDDC software stack. So the question came up earlier about VIDM that was currently used by VCF automation, and if that is replaced by this new broker. And yes, going forward, we have a new broker called VIDB, the VCF Identity Broker, and we'll see a quick little example of that as I go into the demo. Of course, we moved certificate management and password management into fleet management. So again, those are capabilities that traditionally in the past were part of the SDDC Manager that now moved into VCF operations. In addition, we have moved some of the centralized tag management as well as a new feature, configuration drift. And then also we've taken the lifecycle management capabilities, both of the traditional lifecycle management capabilities provided by the ARIA Suite Lifecycle Manager, or something that referred to as the vRealize Suite Lifecycle Management, or VRSLCM. That functionality has been moved into fleet management. And along with the SDDC Manager lifecycle management capabilities has been moved in there as well. And we'll see some screenshots that will show that. And so with that, let me go ahead and just kind of jump in, and we'll go over some of the new capabilities of the fleet management. So this is what the UI looks like here. You'll see there's a new section here, fleet management here on the left. You'll see under fleet management, we have all those things that we just kind of went over. Starting with the life cycle here. So under the fleet management, the life cycle, the patching and upgrading, the binary management, the downloading of binaries, that's all been moved into VCF operations as part of fleet management. And you'll see here currently in 9.0, it's broken into two sections. The VCF management, this is reference to the ARIA Suite Lifecycle Manager, or the manager components, which have traditionally been the operations, the logs, the automation. That's all part of management. So you'll see here we have the ability to go in and set up depots, to manage binaries, as well as to deploy new instances. So here you can see I have deployed VCF operations. I can deploy an instance of operations VCF logs, VCF operations for networks, as well as VCF automation. That's all done from here as part of the management under lifecycle. And then once those are deployed, I can go in and manage the updates and apply patches and updates from here as well. And then if I click on the VCF instances, this is where I would manage the updates for the core vSphere stack, the vSphere, the vSAN, the vCenter, the ESX. Those things traditionally done from the SDDC Manager would be here under the VCF instances. And so we do have the ability here to, again, configure those depots, download those binaries. And again, we have support for both online depots as well as air-gapped and dark sites as well. And here you'll see under here where we can configure the depot under the VCF management. And under the, we have visibility into the tasks. So whenever you're doing, a lot of times when you're doing patches and upgrades, when you're doing downloading things, these are long running tasks, and we have visibility into these through the tasks section. And then, as I mentioned, along with the manager products, we have this capability for the VCF for the SDDC Manager components as well, to include upgrading vSphere and the SDDC Manager. So that's the lifecycle management capabilities. And along with that, we also have the single sign-on capabilities. Again, we have a single identity broker, now referred to as VIDB. And similar to in the past, where we had an embedded identity broker built into vCenter, we do have a version of the VIDB built into vCenter as well. So when you deploy vCenter 9, it will have the VIDB configured. It will be an embedded VIDB, and then you'll have an option to go in and deploy an external VIDB if you so choose. So to help with scale and performance in larger environments, you can deploy an external VIDB, which would be comprised of 3 separate virtual machines that would comprise that. So again, you can choose between that internal, the embedded, or an external. And then you can go in and point all of the components. So NSX, operations, automations, vCenter, you can point them all to use the single centralized identity broker, thus giving us a centralized identity management across the full SDDC stack. So that's something that's long been waited for, wanted by our customers, and they've been waiting for it. And so we're finally happy to be able to deliver that in VCF 9. And I'll go through a quick demo that will show an example of setting that up and what that experience is like. Centralized certificate management, we've had this in the past as part of SDDC Manager. There are several improvements available with VCF 9 to include the ability to manage certificates for ESXi host, as well as the ability to set up automatic renewal of those certificates, along with having a centralized view of all the certificates in our environment. And we do have the ability to configure a certificate authority, and when that is configured, we can generate certificate signing request and actually replace certificates using an automated approach that is non-disruptive. And we'll go through and see an example of that. And along with, so this is kind of showing more of the, I guess this is showing the alerts here in terms of being able to be notified of your alerts. Along with that, we have the password management. So again, password management is another feature from, traditionally on the SDDC manager has now been moved into operations. From here, we can view and manage those admin and root accounts across all the core components. They'll provide a centralized place here. We'll be able to go in and to manage those passwords and to update them as well as to remediate them. So if those passwords get changed outside of SDDC Manager or outside of VCF, we can just go in and update the repository to reflect the new password. A new feature that you'll see inside the Fleet Manager is this notion of configuration drift. So within VCF, you can have multiple workload domains, and those vCenter servers that are managing those workload domains can have a configuration. And from a security standpoint, from a compliance standpoint, you may have certain policies that you want to set in terms of making sure that certain ports and protocols and services may be disabled or may be enabled or vice versa. But anyways, you're going to have a configuration, and you're going to want to make sure that as you have multiple workload domains, you have multiple vCenter instances, how do I make sure that they're all compliant with my policy? How do I make sure that the configuration hasn't been changed? And the same thing for the clusters. We have these vSphere clusters running behind these vCenter servers, and we oftentimes have a set policy that we want to assign to those clusters in terms of making sure that they're secured, they're locked down, and they meet our policy. And when you have many of these, it can be difficult to track these changes across the board. So I think we can all probably relate to an experience where we tried to do a vMotion and it failed because we had a VM kernel adapter misconfigured on one of our ESXi hosts. And we didn't really know that until we hit that failure. So with this new configuration drift feature, we can basically create these policies or these templates, and we can assign them to our vCenter servers as well as to our vSphere clusters. And then we can basically go out and we can monitor the configuration of those components against those policies. And when there are changes and drift occurs, we can be notified that, hey, you have a change was made and you have drift detected. And then that can help us to make sure that we can kind of monitor those configurations and make sure we stay compliant and reduce chances of having problems down the road due to configuration drift because things were changed and we lost visibility of those changes. And so let's go ahead now and let's just jump over to a quick demo. So here I'm logged into a demo environment, and I'm just going to go through a few of those features that we talked about at a high level. So here again, we see our fleet management section in here, and under the identity management, we have under this, we have the identity and access. So if I go here to identity and access, you can see we do have the single SSO view. So we do call this the VCF SSO, not to be confused with vCenter SSO. But we have the VCF SSO. And here you'll see that I have it configured for my management vCenter, as well as operations and NSX and other components here. We can go in here and we can view the settings. So when we set up the identity broker, we can set it up, very easy to set up. And when you set it up, you can set up with the common protocols. Most of the common protocols, as well as the directory services. So Active Directory, LDAP, things like that. SAML, those things are all supported. And then once it's set up, we can just go in and we register our components with the identity source. So here you can see I've registered my vCenter servers and my NSX managers for both my management and my VI, my WLD01, my VI workload domain. And you'll see that's the current state. So now I can basically go in and set up a single source of identity management across all these, so I can log in with my Active Directory account and get access to all these environments based on the role-based access controls that have been configured. Now, in terms of how do I go and add additional components, so let's say right now I don't see my VCF automation in here. So if I want to add that, I can come in here, select automation appliance. It will basically say, hey, I want to enable single sign-on. I click continue. I basically point to the identity broker. In this case, it's running on my vCenter server, so we're using the embedded identity broker, and I configure it. And then once I configure it, it's ready. And then there's some additional steps here because I'll need to go in and set up the necessary role-based access controls within VCF automation for those accounts. But I now have that single source of identity management across my full stack with the VCF SSO and the identity broker. Okay. Switching over to passwords here. So here you'll see I have my list of passwords, and as you can see, it's just a list of the passwords broken down both by the management components as well as my VCF instances. And if I go in here, for example, if I want to change a password, I simply select the password I want to change. So in this example, my operations admin account, I can choose update password, provide the new password, and update the password. The remediate password comes in if, or for some reason, somebody was logged into operations and was to change the admin password directly on the appliance outside of VCF, then that password would not match what VCF thinks it is, and I would need to go in and update VCF for that new password. That's where the remediate would come in. Okay. Along with the centralized password management, of course, we have centralized certificate management. And as I mentioned before, we have a list of all those certificates, and we now with VCF 9 include those ESXi hosts. So here you'll see I have my ESXi host as well. We have a toggle button because oftentimes you'll have a large number of ESXi hosts and, you know, having to scroll the list, so we make it very easy. We can go in, we can set up a certificate authority. So here we have two options, Microsoft CA, OpenSSL. This is functionality we had in VCF 5.2. This is just kind of moved over, carried forward, but it's moved into VCF operations. But here I can go in, set that up. And then once I set up my certificate authority, now I can go in. And so, for example, if I want to update this certificate on this first ESX host in my list here, I go in here, I can generate a certificate signing request. It will go out and generate that request. We see notification up here that request has been created. And then I can go ahead and I can replace this certificate using that CSR. And it will kick off a little bit of a workflow. And then we'll see here that it's now been updated using our Microsoft CA. It has a new expiration date. And so here I can see a list of all my certificates. And you'll notice here we have the auto renewal status. So if I come up here and I activate the auto renewal, then I can basically have it so that as certificates come up on expiration, they can be automatically renewed using that configured CA. All right, so a little quick time check. We're getting here to the end. The last thing to talk about is life cycle. So we talked about life cycle, and here you'll see an example where, you know, the life cycle again is broken into the life cycle for those management components, which are the traditional ARIA suite components. So the fleet management, the operations, the automation, the logs, those components. And then we also have the VCF instances where I can come in and do the updates for my my vSphere environment, my VCF environment, to include my SDDC manager, my vCenter, my ESX host, and you know, the core components there. And so that's kind of a quick overview of the fleet management capabilities moved into the VCF operations under the fleet management section. And so with that, I think that brings us to the end. I see there's a few questions here. So let me just take a couple of these in the couple minutes we have left. So there's a question of, does that mean that the VR LCM is no longer required? Okay, so the VR LCM, or, you know, the ARIA LCM, depending on what name you want to use, that appliance is still deployed. Much like the SDDC manager, you will still see those appliances running in your management domain. What's changed is we've deprecated the UIs for those two appliances, and we have moved them into VCF operations. So when I go into VCF operations, let me come back here to the demo, and I come back here, what I'm looking at here under VCF management, this is the VR LCM. This is basically that functionality moved into the VCF operations. So to answer the question, yes, the VR LCM is still required. It has a new name. We call it fleet management, and it's accessed through the VCF operations as part of the fleet management. Okay, so good question. So a question about multi-factor authentication available with vSphere 9. So yes, you can configure the identity broker with multi-factor authentication. So you set that authentication in your within your component, and then you point the VIDB to that. So yes, you can enable that. The documentation will have the steps for doing that, but we do have support for multi-factor authentication. Question about binary management, such as cleanup or deletion, and if that has improved. We didn't really talk about it, but one of the things, if you're familiar with VMware Cloud Foundation, you'll be with the older versions and the SDDC manager, you'll remember we had the notion of a bundle. And when we would release software updates, they would get packaged into bundles that would get downloaded on the SDDC manager. With VCF 9, we no longer have the bundles. So there's no longer the extra step of, a new version of vSphere comes out, and then we have to wait for the VCF team to package that up into a bundle and make that bundle available through the SCC manager. So one change is we are working directly with the binaries. So as the new binaries get published, you get a new version of vSphere, a new version of vSAN, a new version of ESX, a new version of whatever component. You go in, you download those binaries directly. So there's no longer the concept of bundles. We're now dealing directly with the binaries, and we do have the ability through the fleet management in the depot sections to download both the patches and updates, and to maintain them there as well. So you'll see that it's a little bit easier because we no longer have the bundles to contend with. In terms of managing those, the capabilities are still similar to what we had in the past, where you download them, but if you want to delete them and stuff, usually you have to go out to the APIs to do that cleanup. There's been some scripts and stuff. Not much change in VCF 9 with regards to the management of those binaries once downloaded, but watch for some improvements as we go forward with future updates. That's an area we're definitely looking at. And so with that, I think we're at the bottom of the hour. I think we're out of time, so we'll go ahead and wrap things up.
Yes, thanks so much, team, for being so clear, efficient in covering your topics. You gave us plenty of information to point us all in the right directions so that we can begin exploring VCF 9. So thanks again for doing that with us today. As we mentioned at the beginning, this presentation was recorded and your TAM will make that available to you. And please do join us next month when we'll be looking at VM lifecycle management, as well as the, different notes there, when we're going to be finishing up part 2 of this What's New in VCF 9 section here. So thanks again. We'll see you in August. Bye.
Thank you.